All right. All right, so guys, what we're looking at here is solubility of CO2 in pure water, 25 degrees Celsius, 1 atmosphere pressure. 0.1 atmosphere pressure is 0.0037 molarity. And the common practice is to assume that all of the dissolved CO2 is in the form of carbonic acid, which is produced by the reaction between CO2 and water. Hopefully that you would be able to put that together, that would be the equation of CO2 reacting with water to form that carbonic acid. NMOA, right? Non-metal oxide plus water gives me a acid. Okay. So the question's asking us, what is the pH of a 0.0037 molar solution of carbonic acid? The other thing that I'm going to ask is, what is the concentration of the carbonate ion as well? If you were to look at your reference sheets that have KAs on them, you know which one I'm talking about? That one? Right, the one for brown on the lead that has KAs. The reason why I gave you this is because it has the inorganic acids on it. Carbonic acid, mono, di, triprotic, which one is it? Huh? Sure. Carbonic acid, is it a monoprotic acid, a diprotic acid, or a triprotic acid? Di, because it has how many hydrogens? 2. Okay, 2 acidic hydrogens that can come off. If you look on the aqueous equilibrium constants for your A's, if you look at carbonic acid, actually, if you look at this chart, everything's got a Ka1, right? And I got things with a Ka2 and there's a Ka3. What? Why? Eric, what? Beautiful. It's for the loss of hydrogens. And really, when we think about a diprotic weak acid, we are actually having 2 equilibrium, I don't know if I want to call them states, reactions, okay, 2 equilibrium systems. The first one, we would have carbonic acid plus water. Oops, make that an equilibrium arrow. With the hydrogen carbonate ion and the hydronium ion. And you can think of these really happening in 2 discrete time frames. This one happens first, then what's going to happen? This is an acid, right? Actually, it's, what do you call that? Can it act like an acid and a base? So what do you call those things? Amphoteric, okay? In this case, we're talking about a Ka2. This is the equation for your Ka1. 1 ionization of the 1 hydrogen. Your Ka2 then would cover this, acting as a weak acid to form this and the hydronium ion. Questions at all?
Yeah, the top one should be 1. The H.
Oh, yes, it should. I'm just going to do this because otherwise it'll erase a whole bunch. 1 minus. Thanks, Alex. All right. Now the first part asks us for the pH of that solution. Anybody remember? Question? I make another mistake.
So the H bottom will also be minus HCO3.
Oh yeah. Yeah. Does it look like a 1 now? Thank you. Yes, it does. Sorry. CO3 I just automatically put it 2, but it's not. All right, so You guys remember anything about a Ka1, Ka2 calculating pH of a solution for diprotic?
Yeah, isn't it if there's more than one hydrogen, like H2SO4 or something, there'll be a Ka1 for the original H, and then a Ka2 for the second H?
Uh-huh. But when you're calculating the pH of that solution, is there anything that like, what is the pH primarily going to be due to?
If the difference between the first and the second is greater than 10 to the third, I think it is, then
Mhm.
it's only just the first one.
Good. Okay, if the difference between the Ka1 and the Ka2 is greater than 10 to the third, your pH is really due just to that first ionization process. Okay, meaning this equilibrium is going to lie, the second equilibrium is going to lie so far to the left that this production in this second equilibrium isn't going to produce a whole lot of hydronium that it's going to affect the pH to any great degree. Amanda?
Really sorry, can you repeat the explanation?
Sure.
Thank you.
Well, it's just a rule of thumb.
Okay.
The first equilibrium here is going to be your Ka1. The second one is your Ka2. Both of them produce the hydronium ion, which would contribute to the pH. If the Ka2 for this equilibrium is 10 to the third less than this one, this first one accounts for the hydronium that's going to affect the pH. The other one would be so small it gets lost in how much this one produces. Okay?
So
And we'll look
K1's
at
always
that.
going to be greater than K2.
Okay, yes, yes. Because your first ionization is always larger than your second.
And you mean by a factor of 10 to the third?
Yes, a factor of 10 to
Okay.
the third. Yes.
And so, I don't know if you would call it an intermediate, but that, like, the H2CO3 going to HCO3, is that HCO3 now amphitherotic? Or
Yes,
amphitherotic?
HCO3 is amphiteric, yes. Okay, so. So how, huh?
So
10 to the third.
Like,
Like if your Ka is something times 10 to the negative 2, and your Ka2 is something times 10 to the negative fourth, your pH is going to be due to the first equilibrium.
but
What?
isn't that not by a factor of 10 to the third? Isn't that just a 10 to the second difference?
Guys,
Did I say negative 2 and negative 4?
Yeah.
All right, back up. Say the first one is something times 10 to the negative 2, and then the Ka2 is something times 10 to the negative 11. Then it's only due to the first.
Wait, what about
Sorry.
2 and 5? Is that good or is it
Usually,
three?
yeah. Yes, then that should be fine.
It's two to what happens is
Then you have to do both. And that's what we're going to look at anyway, because I asked you to find the concentration of the carbonate ion. All right, so what do I need to set up here? Oh, I just need an ice table, right? Just a little ice table? Yeah,
just one.
ice. Because I'm going to do this first ice table, I'm going to calculate the concentration of this and the concentration of the hydronium, right? The hydrogen carbonate ion and the hydronium. All right, so what's my initial condition? What are my initial conditions?
0.0037
Mm-hmm.
moles.
0.0037 for the hydrogen carbonate. I'm sorry, for the carbonic acid. Water's not going to enter into my equilibrium expression at all. Do I have any hydrogen carbonate ion to begin with? No, we assume we don't. We assume we don't have any hydronium. Which way is this equilibrium going to shift then? To the right. It's going to make some product. So this is minus x plus x plus x. So this would be 0.0037 minus x, x, and x. What's my Ka1 for carbonic? Yeah. Ka1 is equal to 4.3 times 10 to the negative, oops. Can you read that?
So it's 10 to
10 to the negative 7. So what does that tell you about this x compared to 0.003? Pretty small, so we can say that this is really going to be 0.0037. Right. Expression for Ka is a concentration of the hydrogen carbonate ion times the concentration of the hydronium over the concentration of carbonic.
I have to erase this one.
Mm-hmm.
Don't,
What?
I just like, just to clarify, sorry, I'm confused. So about the 10 to the third thing, so you have to figure out which 10 to the third you divide the K and 1 divided by K is.
Sure.
And then that's great, that's great.
To make that, the difference.
no.
You can never get over
It's the
10
difference
to
of
the
the
third.
power.
by subtracting.
Oh, you're subtracting the power.
Yeah.
Dividing is saying
Well, wait, are you doing it with Ka minus over K2 or K1 over K2?
K 1 over K 2 has to be greater than 10 to the
It
third.
just matters the difference.
No,
K,
because there's a
K1 is always gonna be greater.
Well, that's
Yeah, so it
K1.
doesn't matter.
So K 1 divided by K 2 has to be
It's
greater
just the
than 10 to the
difference of
Yeah.
No,
the.
so it's K1 over K2, not Ka.
K2 is never going to be greater.
There is no really just a Ka.
Yeah, you just said.
Wait, this is the cap.
K1 is divided by K2 greater than 10 to the third, then you use both of
Then
them.
you use K 1.
Yes.
But
What if can K2 be a factor of 10 to the third greater than K1?
Don't
No, your Ka is always going to be larger than your Ka2.
Their concentration
K1,
K.
cause.
Their concentrations are used.
Why is that? Oh, because the first reaction
Because-
produces an HCO3 minus.
Right.
Then you get a base.
Right, and if you think about it on this first one, this has now become overall negative, right?
Yeah.
That H is being held tighter into this
Oh, that makes sense.
species than it does here,
That makes sense.
okay? Michael?
I'm good.
Maybe you already went over this, but why are we looking for CO3 2 minus?
Because I added it.
Because you added it.
I added that. I wanted to do that.
Oh, in addition to the pH.
Uh-huh, yep. All right, so these two, it's x squared over 0.0037, right? You get anything for x? What's x?
3.988 times 10 to the negative 9. Really close to 4.
Yeah, I got 4. 4.0 times 10 to the negative 5th molar, right? What does that equal to? What is x?
Wait,
Huh?
no, sorry, no.
No.
X is the concentration of hydronium ion.
Yay. X is the concentration of the hydronium ion. Is it the concentration of anything else? Yeah, go ahead, Becky.
And also the hydrogen carbonate ion.
Good, the hydrogen carbonate ion. It is the concentration of both of those, correct? Questions? We good? Was my 5%, was I good on that? I was, right? Probably. We'll call it good. All right,
If it's not good, what do you do?
quadratic equation.
Oh.
Will you be able to use polysmall?
Ooh, that was something that's
Able to use what?
It's like an app called polysmall.
The thing that gets deleted.
Not the thing that gets deleted when I clear your calculator. I'm gonna go with the no then.
Well, you delete everything.
Thing said that.
Like you delete every app.
Yes,
Why?
because
Check a
because I'm suspicious by nature.
Yeah.
Wait,
Every time you delete that, we have to reinstall
I
it.
have no idea.
It's a real pain.
Can you just go to a program section and check
No.
to see if we have it?
No.
Why not?
Use mine.
Okay, that's good.
I mean, I have 20 some odd kids.
But-
Really? I
graphics?
don't.
You don't trust us.
No, not even a little.
But it takes like the same exact amount of time.
I don't care.
Maybe you see a spike in someone's grade.
What are they gonna do when you take,
Assume they
5,
choose.
6 times 10 to the negative.
You're allowed to use it for IB testing
56
too.
do they clear the memory?
No.
Are you sure?
Sign them.
Yeah, that was just.
Because
Well,
when
they
we
gave
do-
us all the
when
data
we
we
do-
need, so I don't know if we need to.
I don't know if they do or not.
Mrs. Ludeman, it sounded
Well,
like
why
we
would
could
Mrs.
use
Ludeman tell us to
polysmall
use
on that.
polysmall if we can't?
And the rules for math might be different than chem, because the rules for physics are different than they are for chem too. Becky,
All the app does is find rules, that's about it.
okay.
What?
What?
Don't worry about it.
Oh, is that somebody's computer? Okay.
Yeah, that was
I thought somebody was making. All right,
my intention.
so I can calculate pH now, right?
No.
Sure.
Oh, well, yeah. 'cause
Because
it
I'm
already-
greater than a 10 to the third.
But you can't figure out CO3.
I cannot figure out CO3 to -2, right? I don't know the concentration of the carbonate ion yet, do I?
No.
No. So what do I need to do? I need to look at that second equilibrium for the system.
Yeah.
Room.
Okay. Again, water doesn't enter into it. What are my starting conditions for this equilibrium? What are my starting conditions for this equilibrium? Eric? Where am I? Which one? Okay, and where does it go? For who? For what? For this one? Oh, okay. Does it go anywhere else?
Shouldn't we go on the other side?
Definitely, right? Should go for the hydronium as well. Do I have any carbonate initially? No.
We wrote 4.5, but it's 4.0.
Oh, jeez. Thank you. Which way is the equilibrium going to shift then? Because I have hydronium there.
To the right.
Why is it still going to shift to the right?
You don't have one of those.
Good, because I don't have carbonate yet, so it is going to shift. X plus X plus X. 4.0 times 10 to the -5 minus X. X. Yes, because this is the Ka2 equation. The second equilibrium thing for that second hydrogen is the Ka2. If I had something like H3PO4, I have 3 Kas. Okay. No, it's good. Oh.
So you're doing this to find the concentration of
I'm doing the second one actually to find the concentration of the CO3. Yeah, the carbonate ion. Mhm. Yeah. What do you think I can make an assumption about here?
It's really tiny.
That X is very small compared to the 4.0 times 10 to the -5? What about here?
Same thing.
Same thing. Makes the math pretty easy, right? Because then X is really just equal to your Ka2. Right? If you want to see that. Can I move this?
You have to extend each in the middle on the bottom.
Oh, that, thank you. It's been a long time since I've used this. Right, so Kb is equal to the concentration of CO3 times the hydronium over,
Sorry, isn't this Ka2?
Yeah, this is
yes.
Would Kb be HCO3 going back to H2CO3?
Okay, let's not, no, Kb
That
would
would
be
be-
CO3 -2 plus water, going to HCO3 plus the hydroxide.
So wait, if HCO3 went back to H2CO3, that would be considered Kb.
Not, the reverse one is not
Ka
Kb.
is just the acids and bases reacting with water.
Yeah, but it's HCO3, the conjugate base to each of the C.
No, okay, I get
So it'd be, but it would be this in water.
Yeah, it's just that.
Okay. All right. So this equals x
KB.
times 4.0 times 10 to the negative 5 over 4.0 times 10 to the negative 5. Those cancel. X is just equal to the Ka2. Yes, ma'am. Sure. Sure. Technically, your concentration of your hydronium ion is going to be the concentration you found after the first ionization, which is that 4.0 times 10 to the negative 5th. It is actually technically that plus your Ka2, which is 5.6 times 10 to the negative 11, right?
You can fix that next page.
Man's it.
I heard if you shout input commands, it works.
Why can't you command? Oh, you can command Z that.
Yeah, command Z.
I'm not doing
Say
command.
Command Z.
Alright.
No, there's a
No, it's
Command
right
Z.
there.
Just say Command Z.
Why?
It'll
No.
undo it.
Top left.
Why does it bot? Why? I
Say
don't.
Command Z, it'll undo it.
I don't.
Left.
Screen command.
Top left.
It's that arrow thing, yeah.
Just scream at your
There you go.
Yeah,
Man's it.
Right. All right.
What is going to be rounded?
This is very small compared to this, right? All right. So the pH is really the negative the log of 4.0 times 10 to the negative 5th. Concentration of your CO3 minus 2 is 5.6 times 10 to the negative 11 molar. This should be molar. Right? You good?
If we have to go to all the trouble of finding like the second Ka2 and all those values too, but the IB just want us to add 5.6 times to the negative 11 just for like good practice.
And you just tell us.
Let me answer what you gotta show it to me.
Yeah, like, what do you mean show it? Like, show that 5.6 times 10 to the negative 11 is so tiny?
Oh, no, if your graders, if you're talking, if I'm just asking for pH,
Yeah.
if you just say the Kas differ by more than 10 to the third, so pH only due to the first ionization, that's fine. Okay? If I asked you for the concentration of the CO3 minus 2, you should have done all that work. Right? Right. Questions on that? Yes, Lauren.
How did you go from like adding the 4.0 times 10 to the negative 4 plus 5.6 times 10 to the 11? And then,
Because the 5.6 times to get to here,
yes.
because this is so small compared to that.
What is pH equal?
I didn't do the math. Oh, did I? No, 4.4?
Is it not like big? Is it times 10 to the 11?
Negative 11.
Oh, gotcha.
It's 4.40.
Now it makes sense?
Yeah.
All right. We good? All right. I want to go. To my next problem. I don't use this very much at all. All right. So now let's take a look at 1616. Solution made by adding solid sodium hypochlorite, which is NaClO, to enough water to make 2 liters